Stellar mass black holes are born during the violent deaths of massive stars. If the star in question wandered through space as an isolated star, like our Sun, then a black hole formed as a result of the star's death would also be an isolated black hole. Since isolated black holes wander through space without a companion, they have little to feast upon. As a result, there is little material for them to consume, and so they can be virtually undetectable. Such isolated black holes can also be formed by a different route. Stars more generally birthed in multiples, so as binaries, triplets, or quadruplets, and so on. If one of these stars is a high-mass star, it will burn through its fuel more rapidly than the others in its family. At the end of its life, it will explode in a violent supernova explosion. This explosion can provide a kick that, if strong enough, would break up the family, throwing the black hole out into space by itself. The ejected black hole may even be on a trajectory that throws it out of the disk of its host galaxy. If, however, the kick is small, the binary will remain intact, providing a black hole with a handy food source to munch on for many years to come. Since stellar mass black holes are the end point of a star's life, they can occur anywhere you would find stars. This means that stellar mass black holes are found scattered throughout galaxies. They can be seen around the core of a galaxy or at its outer limits. Almost all of the known stellar mass black holes have been found in binary systems, but this doesn't mean that black holes in binaries are more common than isolated black holes. Instead, this is most likely due to selection bias. In science, whenever we choose a sample based on how easy it is to find something instead of how common it truly is, we introduce a bias. This is called selection bias. Actively feeding black holes in binaries are much easier to spot than their fasting counterparts. This means that we are much more likely to detect stellar mass black holes in binaries when we look out at the night sky. Theorists have predicted that it is more likely that black holes will be isolated. The reason is that there are more ways to make isolated stellar mass black holes. So now we know how stellar mass black holes are born, where to find them, and what they can feed on. What about other types of black holes? Where can we find a supermassive black hole? Let's explore that next.